Welcome to Modern Manufacturing 2020. We are so excited that you're here. My name is Maddie and I am a recruitment specialist here at ECTC. Today we're going to be focusing on a few exciting things that you would come across in the manufacturing process, which usually starts with a problem that needs to be solved or a need that needs to be met. And then those in the manufacturing industry work to create a product that meets that need or solves that challenge. During our time together, we're going to see several demonstrations by ECTC instructors that are using innovative technology right here on our campus that you might find in the industry. Among the things that you might consider when thinking about a career pathway or even changing a career are job security, availability, and salary, which all of our instructors are going to talk about those today. So first, let's talk a little bit about advanced manufacturing and put it into context for those of us who may not be super familiar with all that entails. Advanced manufacturing is the use of innovative technologies to produce products or solve problems. It's a growing field with careers in all sorts of areas like automotive, aerospace, food and beverage, medical, and so much more. Here are some of the employers in our region. You might recognize some of these like Altech that produces bucket trucks, Inowac, TG Kentucky, and Toyotomi that are automotive suppliers, and Midpark that produces structures for things like highway signs and overpasses. And again, these are just a sampling of the many, many right here in our region and in your hometowns. If you're technically inclined, have an interest in STEM subjects, or like working with your hands, you may consider a career in advanced manufacturing. You might be interested to know that Kentucky is third in the U.S. for automotive production, and automotive is the state's top manufacturing sector. Just last year, Kentucky exports totaled $31.36 billion, and our Commonwealth is home to 4,500 manufacturing facilities. That's a lot. Now, the average annual compensation in manufacturing in 2018 was $72,614, and Kentucky manufacturers employ more than 18% of the workforce. If these numbers aren't enough to pique your interest, CreatorsWanted.org estimates over the next decade that 4.6 million manufacturing jobs will need to be filled in the United States. Okay, enough of me talking. Let's jump over to Brent in the CAD lab, who has been working on a project. We'll check in with him a few different times throughout our time together and see if you can guess what he's making by the end of his project. Just as a disclaimer, some of the clips from these videos were recorded pre-COVID. We are currently following all of our Healthy at ECTC guidelines. So let's take a look.
Hello, my name is Brent Doty, and I'm the program coordinator for computer-aided drafting and design. Basically what we do here is we solve problems. And actually I have something up here on the computer that I've been working on to solve a problem for myself. But what my students do is, we work on projects and different assignments, and the whole idea is to give them some kind of a whether it's create a model or create drawings that other programs could use, like CMM. They can make the parts that we actually create. So we work with all the other trades and other areas to solve a problem, and they're the ones that actually end up doing the fixing sometimes and completing the job. We're getting ready to print the part that I've got up here on the screen, and when you come back, we'll see how it's doing.
All right, thanks, Brent. That is awesome. Do you think you know what he's making yet? We're going to check back in with him in a little bit to see more about his progress on that project. But I'm actually super excited about our first demonstration. I got to sit down with our computerized manufacturing and machining program director, Grant Logston, and one of his students. Let's take a look at some of the hands-on experience that his students get as they prepare for advanced manufacturing careers. Hey, so Grant has an EDM demonstration set up for us in the machine shop. Let's go check it out, but safety first.
My name is Grant Logston. I'm Program Coordinator of the Computerized Manufacturing and Machining Program at ECTC.
I think it's a great field to pursue because if you're a student that likes to work with your hands, you like making things, you like taking things apart, putting things together, it's just a great field because we run all kind of different machines, and it's just a great field. We're going to use a wire EDM. It's an electrical discharge machine, a very high-tech machine, and we're going to cut out a 36-tooth spur gear that's actually going to be used on one of our other machines. The work here begins on the computer with Mastercam software. Our students will draw the part, assign a toolpath, generate the code, and then load it on a flash drive that will be uploaded to the machine. After the program is loaded, the EDM, which is an electrical discharge machine, uses 10,000 brass wire to cut out a precision part that will actually be used on another machine here in the shop. You can use any material as long as it's electrically conductive, but here we're cutting a gear out of aluminum. The brass wire comes into close contact with the work but never touches it. As the machining begins, 30 to 40,000 sparks per second will jump from the wire to the workpiece, exploding a path for the wire to follow. The wire follows the path with extreme accuracy to cut out the profile of the part. These machines are incredibly accurate and it takes extreme precision. The EDM can cut materials within 0.2 of a thousandths accuracy. That's like taking a sheet of paper and slicing it thinner 20 times. An EDM and machines like it are used to make parts for aircraft, tool and die parts in automotive manufacturing, for surgical equipment in the medical field, and just about anywhere there's a need for extremely accurate parts.
Hi, my name's Holden. I graduated from LaRue County High School. I'm a student at Elizabethtown Community and Technical College. I'm now working at Atlas as an apprentice, and I'm hoping within a year I can get up to $80,000 a year, and ECTC has helped me get there. What I love most about my job is that I get to be hands-on. We have big equipment that we work on for Toyota, the government, a lot of different companies that need giant stuff made, such as a gear that's 16 feet diameter. And it's nice seeing that we can make a difference in the industry.
I think the cool thing is some of the machines that we have are just absolutely fascinating. We'll use a computer to program something. We'll load it onto a flash drive, put it in a machine, set the machine up, hit start, and we come out with a finished product. And it is an amazing process.
All right, welcome back. That was really cool. It really blows my mind just how precise those machines are. That's one of the things that I was super interested to learn about in advanced manufacturing. It's not just the large, clunky machines in a dark basement like it's sometimes misunderstood to be. It really is intricate and requires great expertise. All right, so we're going to check back in with Brent in our CAD lab and see how things are going with his project.
Welcome back to CAD. Right now we're working on the printing process. I showed you how the creation process went, and now we're working on the actual making of the part. And we're using some filament here. This is a black color, it's a PLA. There's some other materials that we can use, and this is actually what we call additive manufacturing. It's similar to CMM, except it's the opposite, where they do subtractive and they start out with a block of material, and we just start out with this material here and it actually creates it. So this part takes about an hour to print. Some take longer, some are shorter, just depends, but we'll check back here in a little bit and see how it looks.
Gosh, this is so cool. So we've seen the beginning, starting with the computer drafting and designing of what will be produced, and now we've just seen the actual making part of the process. Did you catch that tidbit there, though, where he talked about additive versus subtractive manufacturing? You can really see how the world of advanced manufacturing tackles problems and problem solving from different angles and methods. Okay, so we're going to go to our next demonstration, so let's go to our next stop.
Hey, so I'm in the electrical technology lab with Tim, and he's got a really cool demonstration set up for us, so let's go check it out.
My name's Timothy Cordova. I'm a professor here in electrical technology. I've been doing this for 18 years. So manufacturing, there was a time where we were shipping a lot of things overseas. I think America's realized that the best stuff's made right here in the United States. So I see manufacturing as sticking around for a long time. I also see the rise of robots. Robots are going to be used. They're going to be used in our homes. They're going to be used in industry to clean things when we're gone. So there's going to be a need for people who know how to repair those items. So today we're going to be demonstrating an industrial motor controls tube pick and place that utilizes pneumatics. It's got a photo eye sensor on it. It's computer controlled by a programmable logic controller, and you'll see it use the pneumatics to pick and place a puck off of a conveyor system. So on this machine, this student used a personal computer to create a program that's downloaded into an industrial computer called the PLC. PLC is the brain for this process, as it controls all of the functions on the components. It works hand in hand with the variable frequency drive to control the speed of the conveyor and the dispensing of the pucks, and basically how quickly everything functions. This is important because when this skill is used practically in an industrial line on a much larger scale, everything has to be timed precisely down to milliseconds and even faster. This system uses a photo eye which senses the color of the puck compared to the conveyor belt. The conveyor belt is black, the puck is white. When it sees that contrast, it triggers a sequence of events, including the pneumatics to direct the airflow to engage the slide to pick the puck up using vacuum pressure. To put this in perspective, you replace the puck with a bottle cap, and your robotic system is now assembling bottles of bourbon, Coke, you name it, even ski. So robotic technicians make generally about $65,000 a year, and that's without overtime. So when you think about overtime, think about an extra $30,000 to $40,000 a year depending on that overtime. We also have process control technicians. When you think process control, I like to think about distilleries. I think it's most cool really because when you think about the future, I keep thinking about how it's changed. So from when I started to where it is now, when I started, no robots, now robots everywhere. That's pretty exciting. And when you think about the pay that's going to keep going up and up and up with somebody who needs to know the skills necessary to work on those things, I think that's what's the most exciting.
Gosh, that was such a fun day sitting down with Tim and talking about the future of advanced manufacturing. This field is not only changing and growing rapidly, but it really does have job security and staying power, which is really important as our world is continuing to change. So that may be something that you think about. And another thing you might have noticed in these demonstrations is the diversity of our students in the field. For example, more and more women are finding great careers in manufacturing, and our instructors and employers would tell you that there's nothing that a woman can't do in this career field. So, last second guesses for what you think Brent is producing. We're going to go take a look and see the finished product.
Welcome back to CAD, and this is our last installment, and you're probably wondering what I was making. Well, I'll show you. It was actually a buckle for my backpack to help keep this strap from moving. I don't know if it's going to completely fix the problem, but at least I'm on the right track. Basically, the way the CAD program works is you start out by doing some hand sketches, some hand drawings on a board similar to what I'm sitting at right here. And then they move on to the computer and they start doing the same thing but on the computer. And they move from 2D drawings into 3D drawings and making the models, and then you can either go to 3D printing, you can create the drawings that the other areas use, like CMM or electrical. We work with them to create drawings that they read. We'll create the actual drawings for the solving of the problem, whether we're doing the solving or somebody else is. Most of the jobs are set up as a designer type job. They might be called CAD operator, CAD designer, or just designer. And you can be mechanical or architectural. Usually they make somewhere between $15 to $20 starting off, and it could be more. It really depends on your skill set. Well, the real reason that I like it is because it's cool to solve problems. I have a lot of students that they enjoy making things, not just 3D printing things, but actually designing something that they can say, hey, I did that. Like if you designed a house and you can see it built, and then you're like, hey, I drew that. That's what CAD's all about, solving problems.
All right, so if you guessed a buckle, then you were right. How interesting is that? I love that he mentioned that he wasn't sure if the buckle was going to completely fix his problem, but at least it was going to be a good start. A lot of problem solving is trial and error, but he's working to achieve a goal, and with the technology that's available these days, no matter how simple or complex the problem, you can solve it. Brent actually put those problem-solving skills to work earlier this year when the pandemic started and our healthcare professionals needed face shields but there was a shortage. He came up with a design for the plastic piece that actually fastens the actual shield to your forehead and produced hundreds of those for professionals right here in our community. So, way to go, Brent. All right, one more stop. Are you ready?
Whew. So we're here outside the robotics lab with the engineering and electronics technology program. Marty has a pretty cool demonstration set up for us, so let's go check it out.
I am Marty Sutherland, and I'm a professor here in the Engineering Electronics Technology group. Today we're going to watch a FANUC robot simulate a weld demonstration. What you see here is a FANUC welding robot. We're lucky enough to have 5 small pick-and-place robots and this large welding robot that you would see in the local industry. Our students get first-hand experience programming these robots and running complex programs you'd see in local manufacturing. Now what I've done to set up this demonstration is use a Teach Pendant, the little computer I'm holding, to develop a number of steps for the robot to follow. So it follows an X, Y, and Z axis, which means that it can move up and down and side to side and even rotate. It's really satisfying to see a program developed on a computer and then translated to this powerful yet delicate machine. You might notice the small weld wire that's barely touching the steel part. We're only simulating the welding part of this demonstration just for visibility purposes. The smoke and sparks make it real hard to see up close. Our students, they get to develop this from the ground up. It's up to them to code, troubleshoot, and perfect different scenarios you'd see in the advanced manufacturing industry. Some of the career pathways that you can get into, we've got things like robotics and automation, which would get you over at Matassa, AGC, or some of the places. We've got instrumentation process control, which would be chemical plants like Dow Corning or water treatment plants, or maybe some of the distilleries. We also have the electronics, which goes into like Raytheon, or maybe even LG and EKU in Louisville as well. Those are some of the places you could go. Now some of the salaries you're starting usually around $52,000 a year. With a little bit of experience in a couple, 3 years, most guys are making upwards of 100 or over 100,000 a year. When I talk to my former graduates, the main thing that they say they love about their new job is the pay. They really like that high salary. They can provide for their family, they live comfortably, they can do the things they want to do now. They like the challenges. It's something different every day for them to go to work. They really enjoy it.
Wow, I'm not sure how familiar you are with robotics, But I'm definitely amazed at how our students are learning to program them, to do different tasks like welding, cleaning, all the way to pick and place functions. Many of our instructors have actually hit on one of the biggest draws for advanced manufacturing, which is the pay. While it's certainly not the biggest factor in what makes this field enticing, it is a factor for consideration. Our instructors spouted out a few of those salary figures, anywhere from $40,000 to $65,000 a year to even six figures. But what does that really mean? So let's put money into perspective. The median household income in Kentucky is about $48,000 a year. And we know that a lot of those households have even two incomes. So with a career in manufacturing, you could be providing for your household above the median income in Kentucky. Now, advanced manufacturing isn't only the programs that you've seen today, which are computerized manufacturing and machining, electrical technology, computer-aided drafting and design, and engineering and electronics technology, but also welding technology, one of the most highly paid of the skilled trades, and industrial maintenance technology, where you learn to install, repair, and maintain the machinery and systems that keep industry moving. All of these are two-year degree programs here at ECTC with the options for diplomas or certificates that can be completed in a shorter amount of time. And if you think you want to get a bachelor's degree, you can follow some of the tracks within these programs to transfer into another college or university. If you're thinking of something like engineering, make sure you check out options for knocking out those general education classes at half the cost. Our Associate of Science degree can be completed with electives in any of these programs to set you up for a bachelor's degree that will lead you into a manufacturing workplace. So, if you're ready to find out more about any of these programs or options that we've talked about today, you can visit our website at elizabethtown.kctcs.edu. And there, you'll find information on all of our programs, scholarships, and the application process. If you need any help along the way, don't hesitate to email us at ectcrecruitment@kctcs.edu. Thank you so much for joining us today. It's been a blast hanging out with you.